For centuries, the rules of war have been written by humans. But today, a new author is taking the pen: artificial intelligence. We're talking about a massive shift in military strategy, one that's being driven by algorithms and autonomous robots. It's changing not just how wars are fought, but the very speed of conflict itself.
Just think about that for a second. The idea of a thinking, fighting machine. That used to be pure Hollywood fantasy. But the source material for this explainer makes it really clear. What we saw in movies like Terminator is now literally inspiring the prototypes in advanced defense labs. The age of the algorithmic soldier, it's not on the horizon anymore. It's here. And that immediately brings up two absolutely critical questions that military planners and programmers are wrestling with right now. First off, how in the world do you train an AI to be an effective soldier? And second, once you've made it smart enough to fight, how do you make sure it stays under human control? These are the central challenges we're going to dig into today. Okay, so before a robot can take a single step on the battlefield, its digital mind has to be forged in the fire of countless simulations. But this is where the first major hurdle pops up. Training against dumb, predictable opponents is actually worse than no training at all. Think about an old video game, right? You know the enemies are going to pop out from the same spot, running the same patterns every single time. That's predictable AI. And yeah, you can master the game just by memorizing the script. But on a real battlefield, that's a recipe for disaster. So the goal now is to create adaptive AI, an opponent that learns from you, that changes its tactics, and that's just as unpredictable as a human. Now, here's a really fascinating idea from the source material. There's a formal name for this whole problem. It's called negative training. It's what happens when a soldier trains against a simple AI and learns all these tricks to exploit its weaknesses. They end up developing really dangerous habits and tactical shortcuts that might work in the simulation, but would get them killed in a real fight. So how do you fix this? Well, the solution is a technique called reinforcement learning. Instead of programming in a bunch of rules, you just give the AI a goal, like win this engagement. And then you let it run through millions of simulations. It learns by trial and error. It gets a little virtual reward for good decisions and a punishment for bad ones, basically teaching itself how to become a master tactician. And just to give you an idea of how powerful this is, in one specific training scenario, it took an AI about 75,000 simulated run-throughs to go from a total novice to being virtually unbeatable. And what's really wild is that it developed its own emergent strategies, tactics the programmers never even thought of, simply because they were the most effective way to win. All right, so once you've got this incredibly powerful, trained AI mind, what's the next logical step? Well, you give it a body. We're moving from the digital training ground to a real-world robotic soldier. And look, we're not just talking about some fancy remote-controlled drone here. The goal is to create what's called a command-understanding soldier. This is a huge leap. You don't tell it, move 5 steps forward, turn left. You give it a mission in plain English, like, hey, scout that building and report back on any enemy positions. The AI then has to interpret that intent and figure out its own plan to get it done. So this all sounds like a secret weapon, right? Whoever has the smartest, fastest robots just wins the war. But as it turns out, military strategists are quick to say, not so fast. It's just not that simple. And this leads to this crucial strategic concept called operational ambivalence. It's basically the idea that just having the best tech doesn't guarantee a win. Victory really depends on how well you integrate that technology into your military doctrine, into your culture. It's all about the synergy between the human and the machine. I mean, having the world's most advanced jet is useless if your pilots don't know how to use it as part of a larger strategy. And that brings us right to the absolute core conflict of this entire technological revolution. It is this constant, high-stakes trade-off between the incredible speed of AI and the absolute necessity of human oversight. On one hand, you have an advanced military AI. It can observe, orient, decide, and act in a matter of milliseconds. It operates on a timescale that is just fundamentally beyond human comprehension. And on the other hand, you have a human. Even a highly trained soldier or a pilot reacts in fractions of a second. By the time a person has even processed that a threat exists, the AI has already analyzed it and started a countermeasure. That gap is the entire battlefield. So what this creates is what military planners are calling the on-the-loop paradox. See, to even compete in a high-speed, AI-driven conflict, you have to let the machine make its own decisions. You put a human on the loop to supervise. But the second you do that, you're admitting that the machine is moving way too fast for any effective human intervention, which creates the terrifying risk of losing control completely. And this paradox of control, it opens a Pandora's box of some of the most profound and dangerous risks of military AI. We're talking about the literal ghosts in the machine that keep strategists up at night. One of the most frightening of these is a concept called AI psychosis. This is what can happen when an AI gets fed faulty or contradictory sensor data. It begins to, well, hallucinate. It misinterprets the data and starts to see a threat that isn't actually there, building a completely false picture of reality that could lead to some catastrophic decisions. And you can see exactly how this could spiral out of control. It starts with just one simple sensor error. The AI develops this psychosis and identifies a threat that doesn't exist. It then engages an autonomous weapon. The opposing side's AI instantly detects this action and retaliates. And right there, you've triggered machine escalation, a feedback loop where algorithms are fighting each other at a speed that makes human de-escalation completely impossible. But here's the thing. These risks, they aren't stopping development. Not at all. Instead, they're shaping a new global arms race, primarily between the US and China. And this isn't just about who has more robots. It's about two completely different strategic bets. So here's the breakdown. On one side, you've got the US, and it's betting on quality. It's leveraging its dominance in software to develop the most sophisticated AI algorithms on the planet. And on the other side, you have China, leveraging its massive industrial base to bet on quantity. The ability to produce enormous numbers of robotic systems at an incredible scale. It is a classic quality versus quantity showdown, and whoever wins could dictate the future of warfare. The Pentagon's answer to China's potential advantage in numbers is what they're calling the Replicator Initiative. The whole idea is to field thousands of smaller, cheaper, but smarter autonomous systems. It's a strategy designed to counter a potential wave of Chinese hardware, not with a few big, expensive platforms, but with an intelligent, disposable swarm. So all of this, the self-teaching AI, the command-understanding robots, the paradox of machine-speed warfare, it leaves us with one final haunting question. As conflict accelerates to the speed of algorithms, way beyond the limits of human thought, what is the ultimate role left for the human on the battlefield?